Hello! So, last time we started talking about the exponential function, and we learned how to graph an exponential function. So today I wanted to talk about how do you analyze an exponential graph. So to do that, let's just review very quickly on how we graph an exponential function. So let's say I have f of x is equal to 3 times 2 to the x. Right. So first thing I want to do is make my table of values. So x and y. And I want to choose 5 points, and I tend to center them around 0. So -2, -1, 0, 1, and 2. When I plug this in here, I want to do my exponent first before I multiply it. You can't multiply and then do the exponent. You always have to do the exponent first. Remember, BEDMAS, order of operations. So 2 to the exponent of bracket -2 times 3 is going to give me 0.75. And then when I put 2 to the exponent of -1 times 3, it's going to give me 1.5. Now, 2 to the exponent of 0 is going to be 1. 3 times 1 is 3. 2 to the exponent of 1 is going to be 2. So 3 times 2 is 6. Now, 2 to the power of 2 is 4. 4 times 3 is 12. And you can see that we're already running off the page with this last one, so we won't be able to plot this last point, at least on this graph. If you had your own custom graph paper, you could adjust it, but in this case I don't. So I'm only going to plot the first 4. So at -2, it's at 0.75. At -1, it's at 1.5. At 0, it's at 3. So 1, 2, 3. And at 1, it's at 6. So 3, 4, 5, 6. Now, the asymptote is 0, right? We don't have a k value, so this is our asymptote. And then we can draw in that curve. And then draw in this curve right here. Something like that. All right, so we have our curve, we have our graph. Now, let's take a look at how we analyze this function here. So our domain for an exponential function depends on the situation. In this situation, we don't have any constraints, so our domain is basically all the real numbers for this example. So my domain consists of all the real numbers for this one. Now, if we were looking at an example like this one here, my domain would be from March, this is the 8th, I would probably say, let's say March 1st to March, this is the 22nd, 23rd, 24th, 25th, 26th, 27th, 28th, to the 28th. That would be my domain for this particular one here. So it really depends on the data you have and the situation that you have. But most often in math, we're going to be dealing with all real numbers. Your range is limited though. It's not going to be all the real numbers because you have this asymptote right here. So your range is always going to be based on your asymptote. In this case, it starts at my asymptote. The asymptote is the lowest possible, so my k value, and then it increases to infinity. So this example would give me my ranges at 0, not included, all the way to positive infinity, not included as well. Now the initial value is whenever it crosses the y-axis. So initial value, I'm just going to write IV. In this case is at y is equal to 3. When you read it off of a graph, it's pretty easy to read. If you don't have a graph, then you would have to solve for it. And remember, when you solve for your initial value, you are putting your x as 0. Remember? So set x as, oops, not at. What am I doing? As 0 when you're solving. Now, the last thing that I wanted to talk about is the variation. In this case, our variation is increasing, and it will continue to increase for the duration of the function, because it just keeps going up and up and up forever and ever and ever. So our variation is increasing. Now this is going to be increasing over all the real numbers. Because when we read the interval of variation, we read along the x-axis, and in this case it would be the same for our domain. So this is how you would analyze really quickly an exponential function. Thank you for listening, and I will talk to you guys next time.